Today we're going to solve exponential and logarithmic equations. First equation, 3 to the x equals 11. If I have 3 raised to the x equals 11, I need to somehow get rid of that 3. To get rid of that 3, what I have to do is a log of base 3. Whatever the base of the exponent is, that's what I'm going to do the log with that same base. So I do a log of base 3 to both sides. The log base 3 and the 3 will cancel out, so now we're left with x, and x equals log base 3 of 11. And you could type in log base 3 of 11 in your calculator if you need the decimal answer, and it'll give you the decimal answer. Let's try the next one. Like the last one, we did a log base 3 to get rid of the 3 because the x was in the exponent. We have x in the exponent again, so somehow we're going to have to do a log base 10. Before we do a log base 10, we want to subtract 7 first. Subtracting 7 first gives us 10 to the 4x minus 1 equals 12. And now we can take a log to get rid of the 10. So we want to do a log of base 10 to both sides. And if you remember, we don't actually have to write the log base 10. You can just write log because that means the same thing. So the log base 10 and the 10 will cancel out. We will get a 4x minus 1 equals, instead of writing a log base 10, I'm just going to write log and then of 12. Because you assume there's a base 10. We don't have the x by itself yet, so we must add 1 to both sides. Now, log base 10 of 12 is an operation itself, so I can't add 1 to 12 because I got to take the log of 12 first. So when I do this, I'm going to get 4x equals 1 plus log of 12. Now I still have to get rid of the 4. So to get rid of the 4, we're going to divide by 4, and we have to divide everything by 4. And when we do that, we will get x equals 1 plus log of 12 all divided by 4. And that's our answer. If we need the decimal answer, you can just type in 1 plus the log of 12 in your calculator, hit equals, take that answer and divide it by 4, and then you'll get a decimal, and you can just round that decimal to whatever you need to. Last exponential equation. We somehow need to get the x by itself, so we have to get rid of the 27 and the e. Before we can get rid of the e, we have to get rid of the 27. To do that, we are going to divide both sides by 27. These 27s will cancel out here. No number goes into 50 and 27, so we're going to leave it as 50 27ths equals e raised to the negative 0.5x. Now I got to get rid of that e. To get rid of the e, we have to do a log with base e. If you remember, a log of base e is what we did when we did a natural log, ln. A natural log cancels out the e, so we just do a natural log to both sides. Natural log of 50 27ths equals negative 0.05x. Now we just have to do one more step, which is get rid of the negative 0.015. So we divide by negative 0.015 or negative 0.05. And when we divide by negative 0.05, that cancels out. And you get the natural log of 50 divided by 27, and then that divided by negative 0.05. The problem is you don't want to leave it with decimals and fractions within fractions, so you're going to take that and type it in your calculator. So you would type the natural log of 50 divided by 27, which should give you somewhere around 0.6. And then you divide that answer by negative 0.05, and you should get negative 12.3 approximately. That would be to the nearest 10 equals x. And that one I would definitely round because we don't want these fractions and decimals in a fraction. Next slide. Now we're going to take a logarithmic equation and solve for x. So if I look at this, this is natural log, ln. ln is natural log. That's ln, that's natural log. We want to get rid of that natural log. To get rid of that natural log, we need to take a base that has the same thing. So the base of the natural log is e. So I'm going to do e as the base of both sides. And the e and the natural logs will cancel out. You will get 4x minus 3 equals x plus 9. And at this point, I just get the x by itself. So I would subtract x and add 3 to both sides. Subtract x and add 3 to both sides at the same time. That cancels out the x on the right and the 3 on the left. So we get a 3x equals 12. And then the last step, divide by 3, so we will get x equals 4. Now when we solve these, we do want to make sure that we don't get negatives in the parentheses when we're trying to take the log or natural log. So if I plug it back in, 4 plus 9 is 13. So the natural log of 13 is okay. And if I plug it back into the other one, 4 times 4 is 16, minus 3 is 13. So you get the natural log equals the 16 equals the natural log of 16. So we're good. Next one. Now we have a log base 4 of 2x minus 5 equals 3. We have to get rid of the log base 4. To get rid of that, we need to put 4 as the base of some exponent. And whatever we do to the left, we got to do to the right. So we put a 4 as the base on both sides. 4 and a log base 4 cancel out on the left. So you get 2x minus 5 equals, and on the right, 4 raised to the third power. Well, 4 raised to the third power is just 64, so we're actually solving the equation 2x minus 5 equals 64. And now we just go on from there, add 5 to get 2x equals 69, and divide by 2, get x equals 69 halves. And that's your answer. You could plug it back in to double check to make sure it works out, but it does.